Oh, that's a lot of people coming to hear about automated machine learning. Thanks for coming. My name is Tzvi, and with me is Rachel. We are both program managers from the ML platform team. And we're here to talk about Azure Machine Learning, automated machine learning in Azure Machine Learning. Let's start. We have a really mind-blowing session. Let's start with some framing, AI on Azure. So there are three main pillars to AI in Azure. The first one is knowledge mining, where that is all your cognitive search is done. The second one is apps and agents, and that's bot frameworks and cognitive services, where you can infuse AI into your application. And the third one is machine learning, and that's where we are. And machine learning is the platform that enables data science in Azure, experimenting, generating and building models, and getting them into production. Now, the Azure Machine Learning platform has four fundamentals. One, it is trusted with role-based access control, virtual networking, audit trails, quota and cost management for governance and control. The second is that it is open, and it supports the Onyx model format that enables you to do inferencing, optimize your inferencing for both cloud and edge. And there's built-in support for the open source frameworks like PyTorch, TensorFlow, and scikit-learn, and for the development tools like Python, notebooks, Jupyter Notebooks, and Jupyter Labs. And we've recently just announced the support for R. And the fourth one is that it supports all skill levels. So if you're a data scientist and you prefer to code, then automated machine learning will accelerate your work when you're working on Jupyter Notebooks. Starting really quickly with creating models and then taking them and customizing them the way you want to. The designer, drag and drop, can still build models your way, but you don't have to code. We also democratize AI by enabling automated machine learning for domain expert without a lot of knowledge in machine learning and without the need to code. And this part is very important because it enables you to scale your AI in your organization. Because it's not enough to just have data scientists in the loop. You also need to democratize it and make it available to more people in the organization. So a good example is what happened with the CRM. So who here is familiar with Siebel CRM? Yeah, so Siebel CRM was the 800-pound gorilla back in the late 90s and early 2000 in CRM. But it was only when Salesforce came with their self-service CRM that CRM actually exploded in organization, and you will be able to bring it to more domain experts to create CRM. The same thing happened with BI. Who has analysis services, SSAS, in your organization? Well, yeah, sure, because that's the best enterprise BI there is, and for good. But it's only when self-service BI came along with Power BI and Tableau that BI became so popular in their organization and enabled more insights and adoption boosted. So the same thing happens with machine learning, enabling domain experts to use machine learning while keeping enterprise control. So what is automated machine learning and how does it work? So basically what it does is that it automates parts of the process of generating machine learning models. From taking the data and cleaning it so it's ready for machine learning to creating features. And features are essential so you can create better models and more accurate models. And automated machine learning in Azure ML has very smart algorithms to generate additional features on your data and then feed them into the model creation, into the training. And what happens during training is that automated machine learning is going to try dozens of different algorithms, and each one of those algorithms have hyperparameters that needs to be controlled and set. So it will try also different set of hyperparameters during the loop, and it will go over thousands and even tens of thousands of possibilities in order to give you the best model. So the last part would be, okay, I have a bunch of models. Now I need to select the best one. And automated machine learning will tell you, okay, I recommend that you use this one because that's the best that I think you should use. Now, what differentiates automated machine learning in Azure ML is the fact that there is AI behind the scenes. So there is an automated machine learning service that is trained on millions of experiments. And so that when you bring in your experiments and your experiment and your data, it will say, you know what? You should be using this algorithm and parameter and hyperparameter to find the best possible model. And this will converge into the best model faster. So it's basically AI, training AI. Another differentiator is that it's really easy to deploy automated machine learning models. So because it's all very predefined and the machine knows what it's generated, you don't have to write scripts or anything. You can just click a button and it will deploy it. Okay, so let's talk about the machine learning lifecycle. So we talked about preparing the data, needed to experiment and also deploy, and that is covered by automated ML. But what will happen next is that you'll need to take it into production and operationalize it. And that has its own challenges. Show of hands, who have worked before on an ML project in their organization? Who had tremendous challenges when trying to productionize their machine learning projects? Yeah, latest studies still show that more than 60% of machine learning projects fail when they reach the production phase. And it makes sense, right? It's hard. We know it's hard. Taking software to production is hard. And we've been improving the tools, right, and the processes to do software production for over 40 years now, right? And machine learning is a bit younger when it comes to wide adoption. So what you'll need to do in order to monitor your models and trigger retraining and do a continuous integration and deployment is that you need to package the whole thing. And you probably have more than one model, right? But what happens if you're a big retailer and you want to separate your models by brand or by product category or by store location or, you name it. There's probably other that you can come up with. This can probably pretty easily get you hundreds of models and even thousands. And it's not humanly possible, right, to control all that models that are generated. You need to automate the process. So we talked about how automated machine learning helps you automate the process of model building. But Azure ML also helps you automate the process of taking it to production. So once you created the models using automated machine learning, you can use machine learning pipelines in Azure ML, and you can use ML ops integrated into DevOps to package the whole model pipeline and take it into and operationalize it with continuous integration, continuous deployment, trigger on events, and all the goodness that DevOps bring you. Effectively giving you a model factory. So with that, I'm going to hand it over to Rachel to talk about what we just shipped for automated machine learning and why it is a world-class solution.
Sure. So Zvi gave a pretty nice overview on the machine learning lifecycle. So let's talk about kind of some building blocks that you can use to really make automated machine learning work for you in your scenarios. So just like all machine learning projects, let's start with our data. We really want to make it a point to support your scenarios without you having to compromise. And so with that, we're supporting about 100 gigs of data for training and then 1 terabyte coming soon as well. Additionally to that, we really want to enrich your data and make sure that you are have the ability to create features that are really meaningful for your model. So let me give an example, like Zvi was talking about in the retail scenario. Perhaps we want to forecast our sales for a particular store. Now I'm seeing in my data that randomly, sometimes the sales are dipping down and I'm not exactly sure why. So one thing that we can do to help with this is integrate with Azure Open Datasets. So for those of you who don't know, Azure Open Datasets is basically like a dataset or a database of open datasets that includes things like public holidays, historical weather, US population, and a bunch of different things like that. So maybe if I integrate this with my forecast for my store, I can see that those random dips are actually because there was a snowstorm on that day, or perhaps it was a holiday for that particular region. And this is really, really valuable information to give to our models whenever we're looking into machine learning. Now, the second thing that we're doing is we want to make sure that the data that's going in is quality data as well. So to help with that, we're introducing some data guardrails. And what we do here is we'll run a series of checks over your data and check for things like class imbalance. Perhaps if you're trying to do a classification problem, but you only have maybe 3 instances of one class and 2,000 of another, it's hard to create a really valuable model out of that. So we'll go ahead and alert you of things like that. As well as we'll detect maybe high cardinality columns, things that are no cardinality columns, missing values in your data set, and we can go ahead and take care of things like that for you as well. Okay, great. So now we have data that's in a rich format, and we have it shaped in a way that we want. So the next step is to featureize that data. So automated ML currently supports some automatic featureization and feature engineering. Things like if we have a time column that we think will contribute better to the model, if I separate those hours and days into different columns, we'll do that for you. Happy hour versus non-happy hour, or Monday versus Saturday on my sales. So we'll go ahead and take care of that for you. But some things that we're introducing here is some deep learning support with BERT and BILSTM for natural language processing. So for those of you who don't know, BERT and BILSTM were introduced as text featureizers and have shown some amazing results on building accuracy in the data set. So for example, let me scroll down. The Allen Institute for AI recently announced a new language understanding system. This system was developed for about 20 years, and it was performing at a 60% passing rate on an 8th grade science test. But once they introduced BERT as the core language understanding component, it suddenly increased to 90%. So you can see that 30% jump in how it was performing on that test. And all of this is now available to you through automated machine learning with a simple check of a box. Hey, I want to include this in my training. Just as well, we're doing these automated things, we still want to enable our data scientists who have this prior knowledge on how these features are interacting with the model and enable them to customize the featureization that we're already doing. So for that, they can do things like block transformers that they know won't do the things that they want, maybe override the column purpose. Hey, I don't want this column to be categorical, I actually want it to be text, and featureize it that way. Or they can choose to include, exclude columns during training that they know won't meaningfully contribute to the model. So once we have our data featureized, the next step is to go into training. So automated ML currently supports classification, regression, and time series for our scenarios. But specifically for time series, we're adding some world-class statistical models like ARIMA and PROFIT to include inside of your training, as well as a deep learning model that's TCM-based. So we'll try all of these along with our classical models on your data set, again, to improve some better performance. Now, let's go back to our retail scenario really quick. So we have a model and we're forecasting our sales. But what if I own a whole region and I want to forecast my sales for every single store in that region? I don't want to just produce one model. Like Steve says, I want to produce many models. And you can do that. Well, you can tell automated machine learning, hey, here's where I want to group by. So I want to group by the stores in this region, and we'll produce one model for every store in that region, and this will give you more accurate forecasts for your models. So a quick overview here, we talked about enriching the data, featureizing the data with some BERT and BILSTM, customizing it, enabling our data scientists who are already doing a ton of work in this field, as well as introducing some new world-class learners. So we're increasing our quality of our models, and we're increasing our accuracy. So once I have my model, there's 2 main questions that come to my mind. One, you're telling me all of this is automated, but what did you really do? How do I know that what you're doing behind the scenes actually makes sense to me for all the knowledge that I already have? And then the second is, with this model, how are the predictions actually made? Help me understand what's going on behind the scenes. So for that first one, we definitely want to open up this box. There's a couple of things that we do to help you here. We will show you the transformers that we use to featureize your data set along with the parameters in those. We'll show you any values that we altered in your data set. So things like if we imputed a missing value, here's the column we imputed on, and here's exactly how we did it: mean, median, the most, etc. Additionally, if we split your data into train and valid, we'll show you exactly which rows we put in train and which ones we put in the validation. So there's nothing going on behind the scenes. You're exposed to everything that we're doing. Same thing for the algorithm and the hyperparameters that we're using for the model. Now, for the question on how are predictions made, help me understand how my model is making decisions. How do I know that it makes sense to the stuff I already have knowledge prior to in my business scenario? So how we're answering this question is we're introducing what we call the model interpretability dashboard. And so let's go into an example to kind of explain how this is helping them. So let's say that I'm trying to predict if an employee is going to leave my company or not. I own this company. I'm trying to see, like, is this person happy? Is he going to stay in my company? So in this particular, the text is a little bit small. But in this particular scenario, we're seeing that the most contributing factor to this particular issue is overtime. How much overtime is this person working? And that totally makes sense to us, right? Like, no one wants to work 800 hours in a day. So of course, like, that'll be a contributing factor if someone's going to stay in my company or not. So this is extremely valuable information at training time to see, does this make sense? But what about at inference time? Can I get these insights and maybe take action on it before something happens behind the scenes? And you can. So here's another example where we ran it through an inference time, and we see that this person was actually predicted to leave the company. And the ones pulling down are the reasons why he wants to leave the company. The ones pulling up are the reasons that he would stay. So pulling down, we can see that the top contributing factors are overtime, department, work-life balance, and job role. So perhaps this specific person, we could adjust and make sure that their workload is right for them. Maybe see that the department they're in is the one that's right for them, and perhaps retain that employee in our company. So with a quick overview of what we chatted about here as well, we're increasing transparency, making sure that you guys understand what's going on behind the scenes, and increasing understanding. We want to make sure that what's happening inside the model makes sense for what you know in your business already. And I'm going to pause for those taking pictures really quick. OK, so we've gone through and given a bunch of puzzle pieces into what automated machine learning is and what you can do with it: model interpretability, feature engineering, time series forecasting, data. I would like to bring Anita up on the stage to talk about something a little bit more fun with how automated machine learning worked with Little Caesars. And here you go.
So a little bit about Little Caesars. We make pizzas. We are actually the world's largest carry-out pizza company in the world. We are the third largest pizza chain in the world, and we're the 11th largest quick service restaurant in the world. We have thousands of stores worldwide that are cranking out a lot of pizzas, and my personal favorite, crazy bread, every single day. So what we had to look at was our business problem is, well, our goal is that we have a hot and ready product. So during our hot and ready hours, which are roughly 4 to 8 in every store, the goal is that you should be able to walk in, pick up a pizza, and walk out in less than 3 minutes if it's one of our hot and ready product items. Now, what we were finding is that in some case, we had one single input into our demand model, and that was sales, nothing else. And we thought we could actually do better because we felt that with only one demand model, that we were actually, our customers were walking in, they were waiting longer, they were becoming unsatisfied, and that they would actually walk out the door. And that obviously concerned us. Now you could say, well, Nita, just make a whole bunch more pizzas and have them ready, right? And that way everything's ready, everybody leaves happy, and we're all good. Well, the problem with that is that increases the waste and then ultimately the cost to our franchisees, because we only keep that hot and ready pizza there for a certain amount of time, and that when that pizza expires, we don't sell it to our customers anymore. So we had to strike a better balance, and we knew that, and we felt that if we added some really good strategic inputs, we could improve our demand forecasting model. So what we did is that we worked with Microsoft to implement the Azure Machine Learning platform. And with AML, what we did was that we implemented two key components of that. For our feature engineering, we used Azure Databricks to load in all of our historic point-of-sale data, which was a lot for a company that's been around a really long time. And what we did with that is we also wanted to enhance it with weather and other local events, so we used Azure Machine Learning SDK Open Dataset to kind of enrich that data. From there, the team created thousands of models using the Azure Automated Learning Platform. And what they did was literally a model for every single store and every single hot and ready item for that store. From there, they took those models and they ran them through 11 different forecasting algorithms and utilized hyperparameter tuning. So what happened with that? So my guys would come to me and they'd use all these big words. I'm going to show me the data. That's my motto at work. Show me the data. Prove it to me, because deep down I'm from Missouri and that's the show me state. So even though I work and live in Detroit. So what we did see a great amount of business impact. So what we saw was with this model, the likelihood of you being able to walk in, have a hot and ready pizza waiting on you, and then walking out on time, like we want it to be, increased by 20%. So in a very short period of time, we increased our ability to predict when we should be making those pizzas. So from there, we actually saw, based on our customer satisfaction scores, an increase in satisfied customers, which then resulted in a lower amount of waste and, of course, a lower amount of cost for our franchisees. And the big impact is it just strengthened our Little Caesar brand. People begin to say, oh, they really can deliver on that promise. My pizzas are ready when I walk in. And so that, of course, gave us a tangible impact of a financial impact of having higher sales for our hot and ready model. And just to give you an idea, we have a graph that actually shows, this is for one store and just for cheese pizzas. And you can see the difference between the misses that our legacy model had versus the misses that our new Azure model provided to us. And so we are really looking forward to continuing to hone and build these models out and just make our stores even better. So thank you.
Thank you, Anita. Everybody loves pizza. So from here, let's do demo. It's demo time. I want to show you how I, as a business analyst in a big retail or a grocery store who needs to analyze his sales data, can use Azure Machine Learning to build a better analysis. So let's start. I'm going to second here. Switch to this. And obviously, I'm a business analyst. I'm going to start with Power BI. And here I have a report, a very short report of my orange juice sales. I can slice and dice according to the brand and even according to a store location. And what's really interesting here is the historical data, right? So I can see over time what were my sales for every brand. But what I would really want to do is move from this rear view mirror of looking at historical data to looking forward-looking, right? And look at the predictions of my sales, see a forecast. So let me show you how I can do that with Azure Machine Learning. So first step, I'm going to log into the new Azure ML Studio at ml.azure.com. This is the new environment for all my data scientists in the enterprise. I'm already logged in, and I'm also logged in into my workspace, but I can pretty easily change the workspace to a different one. A workspace, you can think of it as a place where I manage my project or even my Uber project with all my assets here that I'm creating throughout the data science. You guys on the back can see the screen? You can see the work, okay. All right, and like I said before, the studio is for all levels of expertise. So I can code using notebooks in Python or R with Jupyter notebooks. Or I can use the designer for a drag and drop experience. So I can create models the way I want them to. Or I can go fully automated with automated machine learning. So let's start generating some models. I will create a new automated ML run. And the first step is I need to bring in my data. So I can bring in data from my local machine. I can bring data from the cloud. I can bring data from open data sets. I already have my data. Let's take a look at it. I have a preview of the data. And I can see here the time column. That's the week starting. And funny thing here is that all the dates are the same. And the reason is that I have a data point, or a row, for each store and each brand. So that means that if you multiply the amount of stores and the amount of brands, you will get the amount of rows that has the same date. And that's going to be important in the next couple of steps. And then the quantity. And the quantity is actually the thing that I want to predict. This is my sales, right? This is the quantity of sales that I want to predict and show in my graph. And then I have additional information about each store and each date that will come handy when I do the training. All right, so let's select this data set and move on. And the next step would be to configure the run. So I need to provide a name. I'm going to select an existing one, but I can give it any name I want. Then I need to select what it is that I want to predict. So we just said it's quantity. So I'm going to say quantity. And then I need to select my cloud compute. This will be the compute that I will run the experiment on because I'm not using my own machine. It's all in the cloud. In this case, I already have a compute that was created for me, probably by my admin. And if not, I can create one on the fly. And now what I have to do is define the type of the task that I want to do. And I know it's time series forecasting because I know my data is based on time. So I'm going to select time series forecasting. And here is the column that has my time. And now I need to provide a forecast horizon. This is essentially how much further into the future I want the model to be able to predict. And the further in the future that I will let my model predict, the less accurate it will be. So I need to find the sweet spot. I know the data because I'm the business analyst, and I know I have about 2 years of data. So I'm going to select something like 3 months to predict into the future. Since it's a weekly based data, then 12 would be 3 times 4 weeks. I will need to configure one more thing. So if I can control more things here in the additional configuration, but I wanted to show you is the ability to actually set the grouping by. Like we discussed before, I have a time column, but every row in there was based also on the brand and the store. So I'm going to say that I want to split this by, or group this by store and brand. And this will know how to generate different predictions based on store and brand. I can configure more stuff here, but I'm just going to finish, and that's it. Clicking the finish button, automated machine learning will start running and generate models. Now this will take a while. So let's go into a run that was already completed. So you can see this one has already completed, and it has a recommended model. And the model is some kind of random forest. And here's the value that was calculated for the model. The value is a normalized root mean squared error. Why is it the recommended model? Because out of the many, many models, and you can see here I can scroll more and more and more, out of the many different models that automated machine learning created, this had the least normalized root mean square error. That means that it should be the most accurate. What automated machine learning also did, and Rachel talked about it, is data guardrails. In this case, I don't have any issues in my data, but let me take you to a different data set that has some issues. So you can see here that this is a different kind of run. This is a classification run. But you can see here that automated ML checked for class imbalance and said, you know what, everything looks fine. There's no class imbalance. That's important. But it did detect that I have some missing values in the data, and it also fixed the missing values by imputing those missing values based on the strategy that was given to him. In this case, probably automatic, but I can override it, right? All right, let's go back and look at the recommended model. So here are the details on the recommended model. I have also other metrics, not just this normalized root mean square error. I have a bunch of other metrics if I want to make sure that, if I want to compare it, to other models using other metrics. Let's analyze the model further. So I can see here a chart that shows the true value versus the predicted value. This data is taken from the validation set, right? And the ideal would be the green line. The green line would be like a perfect model, which is, it's a never real life scenario. What's below this is you can see the distribution of the data. And you can see that a lot of the data is around like the small numbers, right? And then it gets dispersed, and then I get a little bump at the end. And what makes sense here is you can see that the blue line is the predicted values, and it's pretty good at the beginning where I have more data, right? And it starts to diverge, right, when I get less of a data, which is fine, right? It's perfectly reasonable. And then I want to look at what are the features that made the model work the way it does. So I'm going to look at first the global importance of feature. That means that those are the features that had most impact on the model generically, right, on a global level. So advertising and price, makes sense, right? But I can also dig into any of the data points and see how, which of the features were important there. You can see here it's still the same features, but now I have all the data points. Let's select one here. And this will open up the local feature importance. And I can see that actually price had a bigger negative effect on this specific data point than advertising had. And that might be interesting. I might want to dwell into that. Okay, so assuming I'm ready, I'm happy with the model, I can deploy it. And select if I want to deploy it to a Kubernetes service, which means it's going to be able to work at scale. Or I just want to test it for now using a container instance. And it's also authenticated. So if I want to score the model, I will have to have access to the workspace, and I will also have to authenticate. So I'm not going to deploy now because it's going to take some time, but I will show you that I already deployed one. Here's my deployed endpoint. This is a real-time endpoint, and that means that I can send REST API request to that endpoint, and if I'm authenticated, here's the endpoint. And if I'm authenticated, it will send me back the results. And I can do that from any client, right, that knows how to read the schema of this REST API. And one of the clients that know how to do that is Power BI. So let's go to my data flows. And I uploaded new data. that I want to forecast on. This is not the historical data. And you can see that I don't have quantity here. There's no quantity, obviously, because I don't know how much I'm going to sell. I'm going to edit the entity. This will open up Power Query in the cloud if you're familiar with Power BI. And what I'm going to do now is I'm going to open this AI Insights button. And what this will do is this will go over and scan all the available endpoints on all my subscriptions that I can activate and score upon. And this will come back and give me a full list of everything that I need to score on. Hopefully this will come back shortly. Wait for a second. All right, here it is. And here's my endpoint. And here I can see all the required inputs that the model is expecting. So advert and age 60 and brand. And Power BI did a good job in matching the columns because it has the same name. But I can select any of the other columns if I want. And once I hit apply, what will happen is Power BI is going to send the data to the REST endpoint, score it, and send me back the predictions. And we'll put it in a new column. Right? And then I can use it inside of my data flow. So it's back. And here's a new column called Azure ML.OJ sales forecast with the forecast. And now if I save it into my data flow, I can incorporate it into my reports, right? So let's see how that looks like. I already saved it, so I'm going to go back to my reports with the forecast. Now it required me to do some Power Query, juggling in order to have it all in the same chart. But eventually what I have is I have my historical data, and I filtered this just for the last year, so it's easier to see the forecast. With my forecast, right? And even if there's a small gap, it's fine. I can still forecast. And I can still slice and dice. So if I just want Minute Maid, and I want it in Crystal Lake, then I have it, right? And now I don't only have to look back, I can also predict to the future. So we've seen how I can get real quickly using automated machine learning without writing code on my data. I can create models and deploy them, again, without writing code. And then I can consume those from any reporting tool that I want. In this case, it was Power BI. So we're getting close to the end. I did want to mention other sessions that we have for Azure Machine Learning. Specifically, if you want to learn more about how machine learning is simplified, then on Wednesday, there's one Machine Learning Simplified. And if you're interested to see how to take those models into production with MLOps, there's a great session that Jordan is doing on MLOps. I'm going to keep that for a second now so you can take a look. And then if you want to get started, I would suggest start with the documentation, or just go to ml.azure.com if you already have an Azure subscription. We have tutorials there and how to get started, and it's really easy to get started. That's great documentation. You can sign up for free if you want to get an Azure subscription, and I think it's $200 or something like that of free Azure. And don't forget to give feedback. Just before we start Q&A, I wanted to remind you to evaluate the session, either from the app or from the web. And you can download all the content on the site. And we still have about 5 minutes for Q&A.
So one question is like, how how do we actually like measure the accuracy of prediction? So we've been like playing with Facebook Prophet a lot, like for predicting anomalies. One of the things that we always have a challenge explaining to our managers is like, it's always the question like, how good is your prediction model? How accurate is it? So is there like, in ML, I know like for classification model, you guys have the confusion matrix and other stuff. For regression models and time series, do you have like metrics?
So yeah, so I'm just going to repeat the question. The question is, once I have the models, how do I make sure that they're accurate enough? So I just showed, one thing is I just showed the explainability, and I showed the graphs of how to analyze them. I understand that's not enough. So there are additional things that you can do if you work from the notebooks, if you work from the code. But we are pretty soon going to introduce like additional visualization that will help you analyze model.
And then, sorry, I don't have my mic, so I'll just shout, but one additional graph that we didn't get to show today, but was actually underneath that predicted versus true, is a residuals histogram. So what that'll show you is for every point that was predicted in the data set, how far away from the actual value you were. So the closer to 0 it is, the better that actual model is. So you want to kind of have a curve around the 0 point. But yeah, we'll be adding some more, like Sue was saying.
Can you ingest an RBI data set for the purposes of machine learning?
Sorry, what was the question again? There's a mic there. Over there, yeah.
Can you, when you're ingesting data to do the learning portion, can you ingest data from a Power BI data set?
Oh, no, not yet. But we can ingest data from Azure Blob Storage, ADLS, Gen 1, Gen 2, and there's a bunch of others, not from Power BI yet, unfortunately, no.
Once you've deployed the model, and when you call it to make a prediction, how do you charge that? Is it a call? Is it based on the size of the machine it's deployed to?
Yeah, it's a good question. So the question was, how do you get charged when you call the REST endpoint to do the predictions? So there are two, like I showed, there are ACI, that's for testing, and that's basically you're not charged by usage. It's there's some monthly rate that you just pay for the service, and it comes with the Azure ML service. So that's one, but that will not allow you to scale scoring. And the other thing is Kubernetes, and Kubernetes are deployed on Kubernetes clusters, which are essentially an Azure compute. So you will be charged on Azure compute, the underlying Azure compute.
Okay.
And it's all in the Azure pricing page. Did that answer the question?
It did.
Okay. Yes? They're in public preview now, so it's available for everyone. You mean the ml.azure? Yeah, it's public preview now. You can go and, yeah, you can use it. Yeah. Yeah, it's a good question. So I'm going to repeat that. So the question was, how do you make sure, how do you retrain? How do you make sure it's up to date, it's fresh? So I talked about how to operationalize. Unfortunately, I didn't have time to demo it. So I would recommend if you go to Jordan's session on MLOps. But basically, MLOps is now first-class citizen inside of Azure DevOps. And you can set up your whole CI/CD pipeline using the models that you have registered in your ML workspace, right? And then you can define triggers to start retraining, deploying. You can trigger alerts. You can have a human on the loop to approve the CI/CD pipelines, and it's all like very well integrated into DevOps. Oh, you don't have to actually deploy like I showed. I deployed it just so I can show you how I consume it. But you can stop at just registering the model, have it like there. You don't have to deploy and then do the deployment from DevOps. So make sure, you have all the balances and checks and only then deploy it. Yeah, it's a good question.
So a question for the Little Caesars crew. You had 20% better efficiencies, but did you also see that it drove sales, like the right product was in the store at the right time, and so your sales went up as well?
Yes, we actually did that. 20% resulted in higher customer satisfaction, and then our sales also went up from that.
Was it as drastic as the efficiencies, like 20%, or?
It was more within the 5 to 10% range, but that was still very worthwhile.
Yeah, the efficiencies. I'm
Every
sure.
penny counts, right?
Yeah, exactly, exactly. Thank you.
Yeah.
What types of analysis are supported with the automated ML? For instance, is unsupervised cluster analysis supported with automated?
Yeah, okay, good question. I didn't mention it. So for now, we only automated machine learning only support supervised learning, so classification, regression, and time series forecasting. There's a plan to support unsupervised learning, but it's going to take a while. Did that answer the question fully? Okay.
You had this third option to create ML models with drag and drop.
Yeah.
Which led to the original ML Studio interface?
Yes, so it's now called the Designer. Yes, but it's what used to be called the
Will they
Studio.
replace this?
Yeah, and it's right now, it's integrated into the new Studio.
Okay.
Yes. Okay. Well, thank you very much for coming and listening. Thank you.